So we're going to walk through the stages of fetal development here, looking at the initial stages of the embryogenesis, leading to the implantation and the development of the fetus. So when we look at the overall stages of development, we basically can break it down into 5 distinct phases. The first phase is fertilization. Then we get cleavage, followed by gastrulation and embryogenesis, leading to morphogenesis, leading to fetal maturation, in which the gastrulation phase is the phase in which implantation will occur. This is following the formation of the embryo. And then we get a stage known as fetogenesis. And fetogenesis, it takes place in the process of developing the fetus itself. And so let's take a quick look at the animation of cleavage, where we're going to go from having the single-celled zygote to the multiple-celled blastula and the embryonic disc.
Several of them will hit the egg and try to penetrate it, but one will win, as it were, go into the nucleus, and then there's a reprogramming process where the male and female nuclei have their genes set aside to be turned on and off for early development. Here you see early cleavage stages occurring, and this is one of the early growth phases. As the embryo moves down the fallopian tube, it's going to form an important stage called the blastocyst here in a few seconds. Of course, in real life, that takes days, about 5 days. At this stage, then, I'd like to draw
So let's go ahead and take a look at this development of the embryo from the inner cell mass and in the blastula. And once again, what you remember is that we're going to get differential cell lineages coming out. In this process, we're going to go about developing our anterior-posterior dorsal ventral patterning based off of the point of contact between the sperm and the oocyte, which is going to lead to changes of gene activations within the formation of the embryo and then the fetus, leading to implantation.
animal, and the outer cells give rise to the placenta and other supporting tissues. At this stage, the embryo implants into the wall of the uterus. This is when a pregnancy is really initiated. And now we'll see those blue inner cell mass cells form a disc, and then as the cells continue to grow, they change their physical positions, their kind of geographical relationship to one another. And you'll see that represented here as this disc gets transformed into an embryo. Those lines represent sites where cells are migrating in and out. And here's an important stage when the three
Important in this overall development is the concept of the dorsal lip and the changes of growth signals that come about from the dorsal lip. So the dorsal lip, the DPL, is the remnants of scar from where the sperm went about entering into the oocyte. And what ends up happening is we get two distinct signaling regionalizations. So we get a ventral regionalization and we get a dorsal regionalization. This dorsal and ventral regionalization in terms of signaling is going to lead to differentiations of patterns of cell development and cell migrations based off of the exposure or lack of exposure to BIMPs. Those are bone morphology signals versus the cordon and cerebus signals, the ADMP signals that we see within the dorsal side versus what we see on the ventral side of the blastula as it goes into its embryonic embryogenic phases, leading to the eventual formation of the fetus. So over the next couple of animations, watch what happens in terms of the cell growth and cell lineages, and then watch what happens in terms of the days and the sizes of the actual embryo and fetus as it initiates its fetogenic processes. So we now see the three dermal layers come about from this embryonic disc that started off as a two-layered cell mass. And then we're going to watch a couple more animations here that's going to take us through the differential stages of development leading to the final formation of the embryo and the initial formation of the fetus. So what we have to remember here is that there's key steps that are going to take place in terms of the development here, where each cell is going to start to have a differential proportion of the total amount of cytoplasm from the ovum. And based off of the amount of cytoplasm within each of those resultant daughter cells, we're going to get a different rate of division, and the different rate of division is going to lead to the differential cell masses that we're going to see within the gastrulation and the formation of the embryo.